My dear students, other viewers and listeners, I, Professor Manohar Lal, School of Computer and Information Sciences, welcome you to these two lectures. In the first 45 minutes, we will have a lecture on symbolic logic, and in the second 45 minutes, we will have a lecture on fuzzy logic, what and why. Friends, in order to put the things in context in the first lecture, in which we are going to discuss symbolic logic, I'll go back and first of all I raise a question that why we study various academic disciplines. In a sense it can be said that the various academic disciplines are studied in order to solve human problems. The problems may be of fulfilling the necessities of everyday life, or it may be the problem of having more knowledge about the universe. It may be intellectual hunger instead of physical hunger. Then we can say why there are so many academic disciplines. The answer is that human capabilities are finite, where the nature is infinite dimensional. In each dimension it is infinite. So handling or comprehending the nature in its totality is impossible, and therefore in order to handle the problem of knowing the nature, in order to solve problems, we have divided into various disciplines like physics, chemistry, mathematics, social sciences, etc. So what is computer science? I'll just take 1 minute. It may be said it is the discipline which studies how to solve problems with the help of a machine designed by the man himself. So within that, I'd like to tell you that computer science, being the discipline which is concerned with solving problems with the help of a machine, and generally it is thought that computer science or computers can solve any problem provided we can give a formal explanation or definition of the problem under consideration. So you'll be surprised to know that even before the first electronic computer did its first computing, in the period of 1930 and 1940, some very brilliant mathematicians and logicians proved that whatsoever computer, not just of today, but of any future time, will not be able to solve more than a very small fraction of the problems which we encounter in everyday life. I repeat, the computer scientists or the mathematicians, logicians in the period of 1930-1940 proved that a very, very small fraction, almost infinitesimally small fraction of the problems which may encounter in everyday life can be solvable with the help of computers, not the computers of 2006, but the computers of any time in future will be solvable with the help of computers. This was proved in the period 1930-1940. And second, and equally astonishing result during that period was that out of the problems which are thought of as theoretically solvable, a very small fraction will be solvable in reasonable amount of time. What do we mean by reasonable amount of time? By reasonable amount of time we mean that for example, if we are going comes after 3 days, it is not reasonable amount of time. That is, the time required should be sufficiently small that if we apply the solution, proposed solution, that it can be actually executed and be useful. Actually the solution done should be before the time it is required. So now, what is the consequences of all this, what I have mentioned, of the theoretical results which were proved in the period of 1930-1940? It was proved that instead of going for only algorithmic solutions, algorithm is a very important concept of computer science, and most of the time whenever a problem is given to the students start writing a solution to the problem in algorithmic form. But the results of 1930 and between 1930 and 1940 prove that only a very small fraction of the problems that we encounter or may encounter will be solvable through algorithmic means. So what is the next alternative? So the computer scientists found that we require knowledge in order to solve those problems which may be quite difficult, that is, which are said to be infeasible problems, that is, which cannot be yielded to solutions within reasonable amount of time. In those problems cases, instead of going only for step-by-step solutions, what we should do, we should first find the appropriate knowledge of the domain of the problem under consideration, and once we have found sufficient knowledge, we should encode it, we should organize it, and we should manipulate using this knowledge to gain or to go to the solution appropriate. So, I repeat that step-by-step methods are not sufficient to solve most of the difficult problems which we may encounter in everyday life. Then the next alternative is that we should find the knowledge of the space under consideration and encode it, and then use this knowledge to find the solution. So symbolic logic is one of the ways in which the knowledge may be encoded. So that is the relevance of whatever I have said so far, that knowledge has to be encoded in a form which is convenient for the coder, that is the human beings, and secondly, it should be conveniently understood by the machine also, because ultimately the knowledge is encoded for the purpose of the machine to interpret it, to use it for solving problems. So knowledge representation is not such a simple thing. And that is why that natural language is not used for the purpose of representation of knowledge generally, because it has a number of blemishes which we will discuss during our lecture. And the alternatives were found to the natural language, and one of the most important and useful representation for knowledge, which we call symbolic logic, which further can be divided into propositional logic and predicate logic, was found, in which at least when the knowledge is encoded, the machine can work, can use in solving problems. So friends, this is the background in which I will start our discussion for today. But before that, let us have a look on some of the slides, and here we will major issues about knowledge are not just representation. The slide says that the acquisition of knowledge, it is not an easy job. When you go to an expert, about say medical expert, and you talk to him about the various knowledge pieces which are required for diagnosing and treating diseases, it is not an easy job, particularly when it is to be embedded in a computer system. So acquisition is the very first important issue about knowledge. As I have already mentioned, knowledge is very important in solving difficult problems, but knowledge is not so easy to be gained and embedded in the machine. So various issues which are required to be discussed in respect of the knowledge is acquisition of the knowledge. Then the representation, as I mentioned, first order predicate logic and propositional logic are just two means of representing knowledge. There are others also which we'll discuss. Then the third issue is organization. People generally confuse representation and organization as synonyms and all that. No, it's not like that. It is something like this, that when you have chosen English language to express your ideas, so English is a sort of representation of your ideas. However, whatever you want to say has to be organized in the form of sentences, paragraphs, chapters, and so on and so forth in the form of a book or etc. So the organization is, once you have chosen a representational mechanism, like English language, and you are writing your sentences, then the sentences cannot be written in an arbitrary way. One sentence can be written at one place and another one which is related to this one may be represented very far away. No, it cannot be like that. That is, the sentences have to be organized into a paragraph which have a sub-meaning, a meaning of a part of your ideas which are very closely related, then another paragraph which contains the very closely related part of your knowledge, another part of your knowledge, and so on and so forth. And then these knowledge pieces are clubbed together, which are very close to each other in the form of chapters, and so on and so forth. So organization, my dear students, is a different concept than the concept of representation. I have generally seen the students confusing the two concepts, and this is why I am emphasizing the difference between the two concepts. Then the manipulation. When we have already embedded knowledge, knowledge is not embedded in a computer or a human mind just for the sake of embedding or to be very knowledgeable. No. Being knowledgeable is something else. Actually, the purpose, as I mentioned in the very beginning, is to solve problems. And the knowledge pieces are generally in a form which are not giving the answer to or the solution to the problem under consideration directly. That is, we have to find out, we have to look into the knowledge pieces which are before us and somehow connect these or find out some implications of the statements which are not directly available to us, and find those sequences of steps through using the knowledge given to us to find out the appropriate solution. That is, what I want to say is that the knowledge has to be manipulated. For example, every resident of Delhi is a resident of India, and Mohan is a resident of Delhi. Now, in our heart of hearts or in our mind, we know that because of these two statements, Mohan must be a resident of India also. However, this statement, Mohan is a resident of India, is nowhere explicitly given. So how to find out from the two statements that every resident of Delhi is resident of India and Mohan is a resident of Delhi, and therefore we should be able to conclude from these two statements that Mohan is a resident of India. So this type of conclusions, where a third statement is implicitly or implied in the earlier given statements, have to be found. The process through which it is done is called a reasoning process, and this involves manipulation of the given knowledge pieces. And lastly, maintenance. Maintenance is just not something like this that it is actually because the world is changing very fast, situations are changing very fast. So the knowledge pieces have to be updated from time to time. That is why maintenance is not just whatever is over there, rather it is that we must have up-to-date knowledge pieces in our knowledge base. So friends, I recapitulate. Only very simple problems may be solvable directly through the algorithmic means or step-by-step means. For the other type of problems, there are various mechanisms which cannot be algorithmic only. And one of the approaches for solving problems which are quite difficult for algorithmic means of solution, one method is to use the knowledge, exploit the knowledge. However, knowledge doesn't come free. It is quite a difficult process to acquire, to use knowledge in the computer systems for solving problems, and the various major issues in this respect are acquisition, representation, organization, manipulation, and maintenance. So once I have made you familiar, what are the media for representing knowledge? So please look at the slide. The slide says that mental images are our thoughts in the neurons of the brain. it has been found through the biological research that the neurons are the fundamental units of the brain in which our ideas are stored. Nobody still knows whether it is an English or natural language form or etc. Still it is not clear how the neurons represent the knowledge, what connections and all that, but it is sure that whatever we think, whatever ideas we have, whatever knowledge we have, that is represented, their physical representation is in the form of neurons. Then spoken words of some languages are also representation. Then graphical and pictorial, if there is a scene, there is a hillock, there is a river flowing, the goats are grazing and all that. So those also form a part of knowledge which is not in the form of text, which is not in the form of words, but which are pictorial. And then the magnetic spots on a computer system or computer's memory. These are some of the well-known media for representation of knowledge. Friends, at this stage, you may say that any well-known and well understood mechanism for representing knowledge may be used. No, this is not true. As a little while earlier I said that natural language like English or Hindi are not appropriate for representing knowledge in computer systems so that the computer systems can use that representation to solve the problems under consideration. I'll give you an example here. What is the role of representation in solving problems? Please look at the slide. The slide says that you are required to multiply two numbers, 94 by 90. Now, if it is written in the Roman literals, which is given at the bottom of the slide, then it is X followed by C followed by I, V, which is multiplied by 19. The first is representation of 94, where C stands for 100, because X is on the left of it, therefore 10 is reduced from 100, it gives 90, and the rest is of this gives you 94. Now friends, if you try to multiply the number 94 by 19 using the representation which is at the bottom one, then it is almost difficult to solve it even in using hours and hours together. So what I want to say, that the same number 94 and 19 when represented in decimal form, then it is a child's play to find out the product number. However, if the same two numbers are represented in Roman, in that case, even for the very good calculators of human calculators or very good mathematicians, you can say, though the mathematicians are not supposed to be very good, may not be general, may not be at all good in multiplying and division, but they are expected to do this type of exercise. But I just once again emphasize, if the Roman symbols are used for representing 94 and 19, getting the product is quite a difficult task even for those who are very good at multiplication. Through this, what I wanted to emphasize is that appropriate representation for your knowledge pieces plays a very significant role in solving problems. If not an appropriate representation is chosen for representation of your problems, it may complicate the process of solution and you may not get a solution at all even if the problem is solvable. So friends, appropriate representation is very important. Next we look, and we'll discuss this issue in the next lecture also, that natural languages with which all human beings or a large chunk of the population in a particular part is well versed with, why it is not used? the problems we will discuss later on also is that the natural languages are generally ambiguous and these have imprecision also. What do we mean by imprecision? We say Mohan is a tall boy. Now, according to the Indian standard, a person above 5 feet 10 inches may be called tall. But in that case, Mohan may be 5 feet 10 inches, Mohan may be 5 feet 11 inches, Mohan may be 6 feet, Mohan may be 6.5 feet also, Mohan may be 7 feet also, and maybe higher if like that. What we mean to say is that there are a lot of words, rather most of the words in a natural language may have more than one meaning, as in this particular case, tall may stand for any height from say 5 feet 10 inch upwards. Similarly, there are pronoun references and all that. Mohan hit Sohan. He said like this. Now this he may refer to both Mohan and Sohan. Until unless later on some statement clarifies this context, this ambiguity may continue. So what we mean to say, natural language as a representational mechanism or vehicle for representing knowledge for the computer to manipulate is not a good representational mechanism, and we have to find out the alternatives. Yes. Now we will consider in our everyday life also. Please look at the next slide. This is very common. This type of problems in arithmetic happen. 4 men and 3 women finished a task in 8 days, and 2 men and 2 women finished the same task in 12 days. How much time it takes to finish the task for 1 man and 1 woman? Friends, this type, please continue looking at the slide. This type of problems have been solved since at least more than 1000 years or so, when there was no computer or even small calculators. But even then, this question was not attempted in this very form of natural language. Rather, the mathematicians, one of the very good contribution of mathematician is use of symbols instead of the words which have particular embedded meaning in our minds. So what we have been doing since thousands of years in order to solve this type of problem is, please look at the next slide. That is, we replace the men by M, women by W, days by D, and like that, and the same problem which was expressed or defined in English language can now be defined mathematically as 4M plus 3W is equal to 8D, 2M plus 2W is equal to 12D. And the problem becomes how many days it will take 1 man and 1 woman. Friends, now it is a very simple problem which can be attempted by 6th or 7th standard student to solve it. But if somebody attempts to solve the problem in the form which is given in English, it becomes quite a difficult task. So one of the major contributions of mathematics or other scientific disciplines is use of the symbols instead of the words which have a definite meaning in our minds and convert equal to etc. in arithmetical or mathematical symbolism, which facilitates the solution of the problem. So from here, this simple example, we can see that natural language is even a poor mechanism for solving arithmetical problems which have been solved since thousands of years. And what to talk of very difficult problems in which thousands of statements are there and thousands of variables and environmental factors are there. Those cannot be solved just by using the natural language. I hope you are convinced that we have to find out alternatives for solving problems with the help of computers, especially using symbols. Now, next we enumerate some of the well-known knowledge representations mechanisms used in computer science, and particularly in artificial intelligence, which is a branch of computer science which emphasizes on solving problems using or exploiting the knowledge of the domain under consideration. This is a separate branch of, or within computer science, a special branch where the emphasis is on exploiting the knowledge of the domain under consideration, and there the various knowledge representation mechanisms used are propositional and predicate logic, which we will be discussing today. Then there are frames, scripts, production rules, associative networks or semantic networks, and objects. Some of these we will discuss in our lectures sometimes later on, but for today we will be discussing only the proposition logic, not even predicate logic, though, which is an extension of proposition logic. So friends, after enumerating some of the mechanisms which are used for representing of knowledge, let us go ahead. And knowledge for representing uncertain knowledge, these representations which I enumerated above, predicate and proposition logic, networks, frames, objects, generally these are used for complete and precise knowledge. As I mentioned, in our everyday life, more we are discussing the knowledge which is imprecise. We talk of the weather condition. Today it is going to be a cold day. Now the cold may range from, say, in Indian context, below 20 degrees centigrade. So what I mean to say, that propositional and predicate knowledge representation schemes are used only for representing precise knowledge. However, the knowledge which we encounter in everyday life in order to solve problems is generally not precise, and for that we have to find out the alternative mechanisms like fuzzy logic, statistical and epistemic and other means of representing knowledge which is not precise. So these are alternative means of representing knowledge, some of which we may discuss in our later lectures. Now, as I mentioned, uncertainty may be, ambiguity and or imprecision may be of three forms. Fuzzy, where we are discussing tall, small, cold, hot, etc., where there is one word like hot, maybe representing degrees from, say, 35 to 100 to 100,000, etc., and so on. These are called fuzzy. These are because of the linguistic variables which are sufficient for us to use. However, in the case of machines, those may not be sufficient enough. Then modal logic. It should happen like this. However, everybody should get at least sufficient accommodation to live. Every child must get education enough up to at least 10th standard. This type of statements also form part of the problems under consideration. However, proposition logic and predicate logic are not sufficient to represent this type of knowledge pieces are represented through modal logic. Then we have, go away, please give me this book. This type of things, commands and requests also form part of the problems under consideration. However, again the predicate logic and proposition logic are insufficient, inadequate, incapable of representing this type of knowledge pieces also. And in these cases, another representational mechanism which is called imperative or deontic logic, and finally the belief logic. Mohan believes that an American is taller than an Indian. Now here, how strongly Mohan believes, it differs. or three persons believe the same statement, but they don't believe exactly in the similar manner. Their degree of beliefs may be different. So this is something which is handled properly by another representational mechanism which is called belief logic. So friends, in these 2 or 3 minutes, I told you that though generally we study predicate and propositional logic only, but that type of representations are useful only for representing precise knowledge, where there is no ambiguity, but as I mentioned, that we have to use knowledge which is not just precise, and for that the various representational mechanisms like fuzzy, modal, imperative, deontic, belief logics are also there, just to make you aware the concepts or the names or the disciplines. We will not discuss any of these except the fuzzy one at some later stage. Well, I have already explained to you what is the difference between knowledge representation and knowledge mechanism. So organization, as I mentioned earlier, is that already we have used a representational mechanism like English language, and organization is in the form of sentences. Another question which is generally asked is, what is the difference between logic and psychology? I give you a brief, very small background to the question asked. Actually, logic also derives facts using some reasoning process. Psychology is also involved in reasoning process. Then sometimes the question is asked, what is the difference between logic and psychology? Well, the answer is, please look at the slide. Look at the slide, please. The slide says, logic is concerned with the forms of reasoning. As I mentioned earlier, that Mohan is a resident of Delhi, and every resident of Delhi is a resident of India. Therefore, we should be able to conclude that Mohan is a resident of India. This is a form of reasoning. However, what mental processes are activated in the process of applying this rule is something different. And what mental processes take place in deriving a new fact from the given facts is the domain of psychology. So once again, reading whatever is written on the slide, logic is concerned with the forms of reasoning, where psychology is the study of the process of reasoning, that is the study of what mental processes, underline the word mental process, come into effect when we make a decision or conclusion. So these are two different things. Psychology is mainly concerned with the mental processes, whereas logic is concerned with the various forms. If we are given A, and whenever A is given, then B is also true, then B is true if A is given to us. This type of forms of reasoning are the domains of logic, whereas various mental phenomena go into deciding whether we should use modus ponens or not, is the domain of psychology. Now friends, after giving the background, briefly I discuss propositional logic, which is actually a part of the symbolic logic. Symbolic logic may be said at the top having two major branches. One is propositional logic and the other is predicate logic, or FOPC or FOPL, first order predicate logic. Now, it deals with propositions or statements. Propositional logic deals with propositions or statements. What do you know the difference between a sentence and a statement? This is very important for us to understand, to make further discussion possible in propositional logic. that what is the difference between a statement in English language and a sentence in English language. Friends, a sentence is a statement is a sentence for which we can say yes or no. For example, if I say sun rises in the west, for this sentence I can say the sentence tells us something for which a yes or no answer can be given, and in this part, or true or false answer can be given, and in this case it is false. However, if we say, go away, where do you live? Hurrah, we have won. We take each of these separately and then we see whether we can answer true or false, yes or no. Go away. Now for this particular sentence, we cannot say whether it is true or it is false. Similarly, when I ask, where do you live? You cannot say whether this is true or this is false. The truth or false type of question, it is not. Similarly, hurrah, we have won the match. It is, we have won the match, this part is alright, we can say yes, it is true or it is false. However, when we are expressing a feeling of joy and saying that hurrah, we have won the match, here it is not a question of truth or falsity. It is simply expressing a feeling of joy. Here you cannot say it is true or it is false. So first of all, a sentence in English may be declarative, that is for which we can say it is true or false, may be interrogative in which we are asking a question, may be imperative for which we give a command, or may be exclamatory which is explaining or expressing some feeling of joy, sorrow, etc. Out of these, only declarative sentences are statements. So first of all, we must be very clear that the subject matter of propositional logic is set of statements and not set of sentences. A general sentence may not be a statement. This must be very clear to us. Next, I have given some of the examples. Please look at the slide. Snow is white. Well, it raises a question of yes and no. Snow is white is taken as true. Sun rises in the north. Now this is, but it raises a question. There are two aspects. First of all, sun rises in the north. Whether it raises a question of yes or no, true or false, yes, it raises a question. Secondly, whether the answer is to be true or false. In that case, you can say this sun rises in the north raises a question of truth or falsity. However, the answer in this particular case is false. It is raining now. Now, depending upon the circumstances, depending upon the environment outside, it may be sometimes true, it may be false, but all the three sentences are statements in view of the fact that for each of them the question of true or false, right or wrong arises. So these are the subject matter of propositional logic. These are called atomic sentences. I will tell you what are non-atomic sentences. So we will look at the next. And as I mentioned earlier, that these are the three sentences in English language. Is New Delhi capital of India? Please bring me a glass of water. Oh, you have come. These are, none of these sentences is a statement, because the question of right or wrong, true or false doesn't arise. Now, generally, we don't make simple statements as we encountered on the slide earlier. It is snowing now, or snow is white, etc. Generally, we speak compound and complex sentences representing statements. So how in propositional logic we represent the compound statements? Because as I mentioned, natural language has lot of deficiencies. Add milk to water, add 4 to 3. These two adds are different type of adds. But however, the same word add is used for both of these. However, for the computer to figure out which ad is which one may be quite difficult, and therefore we have to use symbols which are generally not used in everyday context, and similarly we have to use symbolism which is different from the symbolism which is used in everyday language or natural language or English or Hindi. So for that purpose, despite the fact that the symbols may have a parallel in English language, still we use different symbols in order to show that these have fixed meaning. Add milk to water, add 2 to 4 will require two different symbols in order to be distinguished from each other. Please look at the slide. So for this purpose, looking at the slide, we see that for the negation we have the two symbols, and inverted V or ampersand represents conjunction, and the V represents disjunction, and then arrow towards the right represents implication and by implication, etc., with which all of us are familiar. What is the role of these symbols? The role of these symbols is to make more and more complicated statements out of the earlier given statements. Now, examples of compound statements. Please look at the slide. Ram and Mohan are fond of hockey. Apparently, some of us will think that it is a single statement. However, Ram and Mohan are fond of hockey are actually representing two statements. One statement says Ram is fond of hockey. The other statement says Mohan is fond of hockey. However, we have abbreviated the two statements together in the form of Ram and Mohan are fond of hockey. So first, here I wish to tell you that while translating from the English or natural language to the first order predicate logic or proposition logic, we have to see the underlying meaning, and then and only then we should translate. So here, first of all, Ram and Mohan are fond of hockey should be interpreted as Ram is fond of hockey, number one. Number two, Mohan is fond of hockey, and we put an end between the two. If I overslept, then I was late. So in these two cases, when we are symbolizing, generally we will say R stands for Ram is fond of hockey, and M stands for Mohan is fond of hockey, and it will become R and M. Similarly, the other one can be translated. Friends, generally it is not all words which are generally used in the logical sense may be logical operators. Here I'll just explain the word because generally is interpreted as a logical operator. However, it is not so, as will be seen in some of the examples here. Please look at the example. Here I am saying that Dr. Manmohan Singh is Prime Minister of India. It is a true statement. Congress and its allies command majority in the parliament. If we say Dr. Manmohan Singh is Prime Minister of India because Congress and its allies command majority in the parliament, then it is true. The first is true, that is Dr. Manmohan Singh is Prime Minister of India. The second is true, Congress and its allies command majority in the parliament is true, and Dr. Manmohan Singh is Prime Minister of India because Congress and its allies command majority in the parliament. This is also true. But on the other hand, you just think another set of statements which is given on the slide. Dr. Manmohan Singh is Prime Minister of India is true. Cherrapunji receives maximum annual rainfall according to the record of at least last 100 years. However, if we say that Dr. Manmohan Singh is Prime Minister of India because Cherrapunji receives maximum annual rainfall, it is false. So what I mean to say, because in one case true gives true, in the other case true gives false, and this type of words, connectives are not functional and hence not logical. So friends, I gave a sort of idea how symbolic logic came into picture in solving problems with the help of computers. Thank you. In the second lecture, we discuss fuzzy logic. Thank you very much.